Hello, everybody. I hope you're doing well. This is lesson number 11 in Math 100, Liberal Arts Mathematics. All right, so we'll continue to talk about the probability. More particularly, we will learn how to count today. Yes, how to count. 1, 2, 3, 4. No. Counting problems could be very difficult and tricky. So we will learn how to count the different ways certain things happen. That's the first part of this lesson. And in the second part, we'll talk about this whole idea of expected value. Expected value is how we make decisions, every single decision in life, and how these casinos in places like Vegas can thrive because they can, in advance, determine how much money they can make on average. Okay, so based on the law of large numbers, they can use the concept of expected value to pretty much figure out how much they can expect to make, unless of course something drastic happens, like maybe a complete shutdown of a society due to a virus or something. Because sometimes we just can't expect or we can't just predict everything in the future. Okay, but anyway, this whole idea of expected value is very important, and so I hope you enjoy and you learn something on counting and expected value. Okay, so the first part of this lesson is on counting. All right, let's start the count. How do you count these things, right? So there are basically three types of ways where you can count. Okay, so counting problems can be classified into basic three categories. And what I'm going to give you some formulas, but I really want you to do this. Think, okay? Don't try to memorize a whole bunch of things. And in fact, if you look in books, including our textbook, it'll give you formulas and it'll tell you when to use formulas, okay? That's a bad way of learning this stuff. I want you to be able to critically think so that you know which problem to apply, which formula to apply. But even with that, the formulas could be very confusing. And theoretically, formulas are great if you're doing mathematical research or something, but in real life, to be able to think and come up with the numbers of ways something could happen, that's a lot more important. Okay, so I'm not going to emphasize the formulas, even though I may show you some. This is what I'd like you to really do in this class, all right? All right, so the first one, the three basic types are multiplication, permutations, and combinations. Each of them is slightly different, although they do share many of the similar ideas. The multiplication rule is the basis of all counting. If you have things occurring in multiple stages or steps or a sequence, this is what you do, okay? So here's an example. Let's say you have two choices. You go to a restaurant and they have a, sort of a fixed menu. Sometimes in Japanese restaurants, they call omakase or something, right? And so they have, let's say in this particular place, you have an appetizer and an entree and a dessert, but they have two choices for the appetizer and 4 entrees to choose from and 3 dessert to choose from. Okay, the question, how many options are there, right? You realize that these are independent choices, independent events, right? So regardless of which appetizer you order, you can choose one of the 4 entrees and one of the 3 desserts. And in the case like this, you have 2 choices for the appetizer, 4 for the entree, and 3 for the dessert. And so that turns out to be 24. You can do a diagram again, a tree diagram, right? So you have appetizer 1 and appetizer 2. And regardless of which one you choose, you have entree 1, entree 2, and so on. This is a big tree. And for each one of these, you have 3 choices for desserts, the dessert. Okay, so it ends up with 24 branches. And so that's a way to think about this. Another example. Let's say you have 5 flights from LAX to Chicago. Chicago's airport is called ORD, even though it's O'Hare. It used to be called Orchard Field, and that's why the ORD comes from. You have LAX to ORD, you have 5 flights. And then from Chicago to Atlanta, you have 3 flights. And the question is, how many possible routes are there between possible flight, okay, combinations are there if you are to go from LAX to Chicago and then from there to Atlanta? The answer, you have 5 choices for the first leg and the 3 choices for the second, and that's 15. Again, you can draw a tree diagram. Okay. How many 7-digit phone numbers are possible? Oh, that's an important thing if you are, in charge of the communication system for a city or something. Do we have enough phone numbers if we have only 7 digits in our particular area code? And the way to think about this, and you may think, why is this a problem with multiplication rule? All right, think of 7 digits, like 5551212 is one possible phone number, right? And so you have 7 digits, 7 spaces to be filled, each with 1 digit, right? And you have 0 to 9, that's, by the way, 10 digits we have in our numeration system. And so how many ways are there? Well, there are 10 possible ways to choose the first digit. And then regardless of the first one, let's say the first number is 2, but you still have 10 digits to choose from for the second, and then 10 for the third. And in fact, every digit can be filled completely independently by 10 digits. So that's 10 to the 7th, 10 times 10 times 10 times 10 times, just go ahead and write this. 1, 2, 3, 4, 5, 6, 7. And of course, you write this as 10 to the 7th, and that is 10 million. Remember, 10 to the 6th is 1 million, okay? So that's the answer. Remember, you just apply the multiplication rule. You just multiplied each possible case, and you multiplied by the number of boxes you had here. Okay, so that's 10 to the 7th and 10 million. Of course, you can stop and ask a question like, is this enough? Like, for instance, if everybody in LA is supposed to have a 7-digit phone number, which we do, in the entire LA area, is this enough? And of course, the answer is no. We have more phones, including cell phones, office phones, home phones. This is not nearly enough to cover the entire LA area. And therefore, what did they do? They divided up the area into a bunch of smaller area codes, right? So some people have 661, some people have 818, some people have 213, and so on. And in each area defined by the area code, you can have up to 10 to the 7th or 10 million. And actually, it's not 10 million because they have all kinds of restrictions. Okay, nobody has a phone number like 0000000, right? So they have restrictions so that this number is actually less. All right, number 2, the second category of problems in counting is called permutations. It's very important for you to know what a permutation is, all right? So we're talking about arranging a certain number of things, like maybe people or songs or books or CDs or device or whatever. We're arranging a certain number of items, objects, and list them in a certain order. And no repetition. You can't use the same thing again and again, all right? So here's an example to keep in mind. Let's say you have 5 songs you want to listen to, okay? And you want to create your own playlist of 5 songs. And each song is going to be played exactly once in this playlist, okay? In other words, you can't, choose, you have a favorite song out of 5, so I'm just going to play that song 15 times. That's not the way we do this. In this context, when we are talking about permutations, let's say 5 songs need to be arranged in some order, no repetition. All right, so the question here, and again, I'm going to emphasize this, no repetition is allowed. And the order matters. Okay, now this is very important because in the last case, combinations, the order doesn't matter. And sometimes the order doesn't matter, but sometimes the order matters. And whether the order matters or not, matters when you count, okay? So let's say you have 5 songs to listen to. How many ways? Well, again, remember, think is the key word here, okay? Think of how you would arrange these 5 songs. How many songs can you choose from for your first song? Song number 1, you have 5 songs to choose from, right? Let's say these songs are called A, B, C, D, E, and E. You can pick C for the first song to listen to. Now that you have one of the songs chosen, how many ways can you pick the second of the 5 songs? And the answer is 4, because one of the 5 choices is gone now, right? All right, so after choosing the first 2 songs, you only have 3 to choose from for your third choice. And after that, you only have 2 to choose from for your fourth. And once you choose the first 4 songs, guess what? there's only one song left and you don't have much of a choice. So you have one song to choose from for your last song. So you multiply all of these, okay? And so that turns out to be, in terms of a mathematical formula, this is called the 5 factorial. You do 5 times 4 times 3 times 2 times 1, and that's 120. So you can construct 120 different playlists out of 5 songs, okay? So that's called the number of permutations. Each of these arranged list of 5 songs is called a permutation, right? So you can come up with your permutation and somebody else can come up with his or her permutation. And in fact, you can have 120 people coming up with a different permutation from everybody else. All right, the second question under permutations is, let's say you have 8 runners in the heat. You know, a heat is when they try and run and see who will go into the finals and so on. How many different outcomes are there for the first, second, and third place winners? Okay, so this time, notice here, back in the first problem, you multiplied all of these, 5, 4, 3, 2, 1, all the way down to 1. This time, you are only choosing 3 winners, the first, second, and third. And by the way, do you realize why there is no repetition and order matters? The order matters because you have first and second and third place winners, right? And you don't want to say, well, you know what, all 3 of you did great, so, you know, I don't care who won the first. No, that's not the way sports works, right? So the first place, second place, and third place winners must be determined in an order. That's the order matters. And no repetition, because nobody is going to win first, second, or second and third places, right? The repetition is clearly not allowed in this situation. So the way you think about this is you have 8 runners. Any of the 8 can come out first, assuming that they are fairly competitive, right? But once the first person has reached the goal, you have 7 to choose the second place winner from. And once those 2 people have finished the race, you have 6 more people running for that third place, right? So the answer is going to be not 8, 7, 6, 5, 4, 3, 2, 1, all multiplied together. Only the first 3 numbers starting at 8 are multiplied. 8 times 7 times 6, and that's going to be 336. Now, you know you can use a calculator, so you feel free to use calculators. But the concept is important here. You start with this number, and how many numbers are you going to multiply? That's the number of boxes you're going to draw, okay? All right, similar question. You have 10 books, okay? You want to pick 3 to read. And the order is important for some reason, okay? In other words, if you read the book ABC, that would be considered a different permutation from ACB or BCA or CBA, right? So the order is relevant. How many ways can you choose a reading list of 3 books out of 10? Right? So again, you can draw 3 boxes because you are picking 3 books in order, and the order is important. By the way, no repetition. You are not going to read the same book twice. And so 10 times 9 times 8 is your answer. Okay, and that's already a large number, 720. Okay. Hopefully you can explain the pattern of all of these permutation problems and see how that works. Okay. The order is important. No repetitions allowed. Make sure you understand this. These are the 2 important conditions for you to use the permutations formula. All right. So what do you do? Multiplication. So, and again, I don't want to write a rule here. So you multiply numbers and then descending by 1, and I'm not going to write down all the technical parts of the rules, but number of numbers you multiply is exactly the number you choose, right? And the number that you start with is the possible number of things that you can choose from. Okay, so that's how you can do that. Now I could write a formula. The formula, I mean, maybe I'll write the formula later. Okay. Should I do that? Nah. I'm not gonna even give you the formula here. Well, okay, the formula looks like this. P sub n r is n factorial over n minus r factorial. Okay, and the reason this is hard to use I have to explain every detail here. And I have to explain why this works. If you know this formula already and want to use that, that's great. But otherwise, don't worry about this, okay? You don't need to know that. But you do need to know how to think and how to write these multiplication problems to match the number of permutations. Okay, that's where the thinking comes in, and I think this is a much more critical ways and a good way to learn this than memorizing the formula and try to apply it, because that's just not good. All right, now combinations. This is the trickiest of the three types of problems in counting, right? So here, the combination is a situation where you're picking things out of a larger set like before, but this time the order is not important, okay? So there are situations the order doesn't really matter, okay? For instance, you are to pick 3 committee members out of 4 candidates. So you have 4 people, let's call them A, B, C, D, right? So you have Alice and Bob and Charlie and D, okay? So these 4 people are interested in becoming committee members, but you can only choose 3. So how many? Notice here the order is not important because the committee members are all equal. You are not picking first, second, and third place winners. So the order, if you pick A, B, and C, it's the same thing as picking C, B, and A, or B, C, and A, right? And the reason, here, let me go ahead and write this first for combinations. I'm going to erase this, right? Just hold on tight here. All right, so for combinations, the 2 things that you should know and you should verify is as follows. No repetition. So this is very much like the permutations problem, no repetition. Because in other words, if you're looking for 4 candidates and 3 to choose from, you can't say my 3 members are A, and A. That would be repeating A more than once, and that's not allowed. And then the order does not matter. The order is irrelevant. That's what I mean, okay? And so like I said, this is the difference between choosing first and second and third place winners and choosing 3 committee members. So here, let's say you have A, B, C, D, okay? If the order were important, that's the way you think about this in combinations. If the order were important, if you were to choose first, second, and third place winners, then there are, this would be a permutations problem. That's 4 times 3 times 2. That's 24 different ways to choose the first, second, third place winners. Okay. Now I'm going to list all those 24 ways so that you can see what's wrong with the answer 24 when you're choosing 3 committee members. Okay. If the order were important and if you had to choose 3 out of these 4, here are the 24 different ways. A, B, C. A, B, D, A, C. Now, if you choose A, C, you can have B or D for the last one. So, you have these 2. So so far you have A, B, and C and D, and A, C, followed by B and D. You can also start the first 2 choices as A, D, and then, of course, you can have B or C for your last candidate, right? And these are the 6 ways or 6 different choices if you start with A, candidate A. Let's say you pick B first, and then you can have BAC, BAD, bad, BCA, BCD, BDA, BDC. There should be 6 choices if you start with B as your first candidate, right? And the same thing happens, or similar thing happens, if you start with a C. So what happens? Well, if you start with C, let me move this up, not that high. C, A, B, C, and this is again alphabetical order, lexicographical order. C, A, B, C, A, D, C, B, A, C, B, D, C, D, A, C, D, B. Okay. So those are the 6 choices if you start with C. If you start with D, you also have 6 choices, DA, and then DAB, DAC. Remember, you can't have DAD, for instance, because you can't duplicate the same letter. So DAB, DAC, gotta be careful, right? DBA, DB, that doesn't look like a D. Okay. DBA, DBC, and then you have DCA, DCB. These are the 24 different choices of candidates if you had to pick 3 and the order is important. But remember, the order doesn't matter, right? So the point is, I listed all 24, but many of them are actually the same 3 committee members, okay? In how many ways did I pick A, B, and C? Well, here's one. I picked A, B, and C here. I also picked the same committee here, ACB, right? I also picked BAC. That's the same as ABC or ACB. I also picked BCA, right? And then how about CAB, CBA? Okay, now, of course, once you have D, that's not the same committee. But look, I have chosen A, B, and C as the 3 committee members out of 4 in 6 different permutations. All these 6 different permutations should be considered one combination. Does it make sense? So even though I have 24, okay, each combination was actually written as 6 different permutations. Now, why 6? Well, because every time I pick A, B, and C, I can permute, I can permutate, I can change the order in 3 times 2 times 1 ways. That's 6 different ways, right? So the answer, how many times did you list the team A, B, C? That's 6, right? So the answer is, even though I started with 24 permutations, each combination comes in group of 6. Okay, so there are 6 different ways of writing every combination. So I have to divide this by 6, and the answer turns out to be only 4. That's the number of combinations of when you have to choose 3 out of 4. Okay, so I know this is complicated. Yeah, the combinations is the hardest one to figure out. But that's the answer here. And so the only combination we are really talking about, there are only 4 combinations. What 4 combinations? A, B, C is one, right? And then A, B, D is another one, okay? And then A, C, D is another, and then B, C, D. These are the only 4, okay? In fact, everything I wrote, all the 24 that I wrote, is it belongs to or becomes one of these combinations if the order were not important. So for instance, I have DAB here, or DAB appears here, okay, right here. And then how about DCA? Well, DCA is written right here, right? And so if you can switch the order, if the order didn't matter, you don't have 24 permutations. You have 24 permutations, but you don't have 24 combinations. You only have 4 combinations. So how do you do this? You know, how do you figure this out? Okay, so here's the answer to this. Let's do 2 problems which are related to each other. In how many ways can you pick 4 out of 7? Okay, so let's say you have 7 children in a group and you have to pick 4, okay, to do some game or something. How many ways can you pick 4 children out of 7? The order is not important. The no repetitions allowed. The answer, first calculate the permutation numbers. How many permutations are there if you are to pick 4 out of 7? The answer is 7 times 6 times 5 times 4, right? That would be the number of permutations of 7 if you have to pick 4 out of 7. And the order is important, but the order is not important. So just like in this case, you have written the same permutation many times, same combination as many permutations. How many permutations are written for one combination? The answer is, remember there are 6 here because there are 3 factorial, 3 times 2 times 1 ways of writing the same combination. So here you have 4 times 3 times 2 times 1 ways. That's 24 ways of writing the same combination. Okay, in other words, when you list all of these permutations, all 24 of them are exactly the same combination, 24 permutations, are represented by just one combination. So you divide this number by 24. Okay. And by the way, if you write it this way, you can often cancel some of these, right? And then 3 times 2 is, basically 6, right? So this turns out to be 35. You don't even have to have a calculator to calculate this. So that's the answer to this question. Okay, let's say, how about 3? If you had 7 children, and this time a game involves only 3 players, so you pick 3 out of 7. How many ways can you pick 3 children out of 7? Okay, think of the permutations first. If this were a permutations problem where the order is important, then 7 times 6 times 5 is the number of ways to pick 3 out of 7, if the order were important. But the order is not important here. So the combination, the permutation ABC is the same as VCA and CBA and so on. So you divide this by 3 times 2 times 1. That's 6 different ways, just like here, 6 different ways of writing each combination as 6 different permutations. So you divide. And so that's the answer to this question. And of course, you can cancel again. This also turns out to be 35. What? You say, well, how can you get the same number, right? I hope you understand why you are dividing the number of permutations by the corresponding the factorial number. And so they just turned out to be equal to each other. Now, by the way, that's not an accident that you get the same number. Okay, philosophically speaking, listen carefully, picking 4 out of 7. Let's say you have 7 children, you have to pick 4. That's equivalent to excluding 3 out of 7, right? So when you pick 4 out of 7, you're really making a decision as to which 3 will not be a part of this game. So that's why this number and this number happens to be equal to each other. And so if you want to look for the combination of picking 5 out of 7, that would be the same as 2 out of 7. Because picking 5 is equivalent to picking the 2 that you are going to leave out, when you pick 5 out of 7, right? Right, so that's why these numbers are equal to each other. All right, so here's a quick summary of this. And then I will just ask you this question about 31 ice cream flavors. I'm not sure where this number came from. Okay, so the summary is this. If the repetition is allowed and order is important, like the phone numbers, you use the multiplication rule. This is the easiest one. Okay, the repetition is only in this problem or type of problem, the repetition is allowed. If the repetition is not allowed, then you have to ask this important question. Does the order matter? If the order is important, like playlists, then you use permutations, or you count the number of permutations. If the order is not important, like in last case of picking a committee, then you use the ideas in combinations. You choose, and so this is the hardest one, okay? So this is to find the number of permutations and divide it by the number of things or the elements or the people that you are choosing, factorial. So if you're choosing 3 out of 5 members or something, then the denominator will be 3 times 2 times 1. All right, so let's go ahead and answer this question. You go to an ice cream store and you find out, to your surprise, there are 31 different ice cream flavors, and you are allowed to pick 3 flavors. So you can have a triple cone. Okay, you get to have a free triple cone out of and you can pick 3 up to 3, well, let's say 3 flavors out of the 31 flavors available at the store. How many triple cones are possible if, number 1, you can specify the order and you can repeat any flavors. So you can say, all right, my 3 flavors are chocolate, chocolate, and chocolate, just because I like chocolate. Okay. Or I can say chocolate, vanilla, chocolate, but I want the vanilla to be in the middle. That's reasonable, right? So if you can specify the order, and if you can repeat any of these flavors, then how many ways can you choose? Number 2, you can specify the order, but somehow you can't repeat any flavors. You have to pick 3 distinct, different flavors, but you can specify the order. You can do vanilla, strawberry, and chocolate. And I want the chocolate in the bottom because that's the last thing I'm going to taste. And I want to choose the best until the last. Okay, so you can specify the order. If you can specify the order and you have to order 3 distinct flavors, how many possible triple cones are possible? And number 3, you don't specify the order. You just pick 3 distinct flavors. So not repetitions allowed, and the order is not important. The order doesn't matter. In this case, how many possible ice cream cones are available? All right, so answer these 3. And when you think you get the answers, you come back to the second part of this lesson.